Hi, I'm very sure many of you have came across the term deep learning. Now, what exactly is deep learning and what are applications for it? Deep learning is a subset of machine learning in artificial intelligence that is inspired by information processing and distributed communication nodes in the human brain. Deep learning architectures such as deep neural networks, recurrent neural networks, and convolutional neural networks have been applied to fields including computer vision, natural language processing, bioinformatics, as well as the field of focus of our project, Fintech, which is technology that seeks to improve and automate the delivery and use of financial services. For our project, we'll be specifically focusing on the application of deep learning models for the Fintech task of stock trading action prediction. Although past research on the use of deep learning models for stock market predictions provided us with evidence that deep learning models can perform well for stock market prediction tasks, past research often do not take into consideration if the data used to train the deep learning models fully captured the variations and economic trends present in stock data necessary for learning the task of stock prediction, and minimal work has been done to study the effects of inducing variations to the training data used to train the models on the ability of the models to learn the task of stock market predictions. The objective of our final year project is to conduct an experimental investigation on the effects of introducing different variations to the training data used to train deep learning models on the ability of these models to learn the task of stock trading action prediction. The variations introduced should allow us to better understand how various variations present in the training data affect the ability of deep learning models to learn the task of stock trading action prediction. The variations should also take into consideration stock market specific factors likely to affect stock prices and movement. For our experiments, we introduced 6 different kinds of variations to the training data designed with the intention of trying to determine if these specific variations, when introduced to the training data, will better allow the deep learning models to overcome the difficulty of learning the task of stock trading action prediction. The 6 variations used in our experimental investigation are varying the dimensionality and presentation of the training data to the deep learning models, varying the number of past trading days to be used as the look-back period for the stock data of each training sample, varying the ratio of the number of training samples for each class in the training dataset, varying the stock cycle phase in which stock data is extracted from to build the training datasets, inclusion of stock price data of another stock from the same business sector to the training dataset, and lastly, varying the category of the market capitalization of the stocks used to build the training dataset. For our project, our experimental investigation was conducted using 2 types of deep learning models, convolutional neural network, as well as long short-term memory recurrent neural network. From the experimental investigation, we were able to better understand the effects of introducing certain types of data variation towards the ability of deep learning models to learn the task of stock trading action prediction. From the experiment, we were able to conclude that the format in which data is presented to deep learning models affect their ability to overcome the difficulty of learning when training for the task of stock trading action prediction. With CNN models trained using training samples presented in the form of image representation, and LSTM models trained using training samples presented in the form of time series representation, able to overcome the difficulty of learning better. The experiments also provided us with evidence that the number of days used as the look-back period for training samples fed to deep learning models does affect their ability to identify the cycle and the trend of the stock for them to accurately make stock trading action predictions. In order to better overcome the difficulty of learning for stock trading action prediction, CNN models should be trained on training data using 20 look-back trading days, and LSTM models should be trained on training data using 5 look-back trading days. Other findings of the experiments include CNN models trained with a training dataset built using only a particular stock cycle phase are generally able to achieve high prediction accuracies for making predictions on dataset built using data from the same stock cycle phase, and training CNN models using training dataset supplemented with supporting price data of the market leader stock from the same business sector aids the models in their ability to overcome the difficulty of learning the task of stock trading action prediction. Also, CNN and LSTM models trained with training dataset built using stock data of large market capitalization stocks overcome the difficulty of learning better than the models trained with training dataset built using stock data of small and medium market capitalization stocks. Now, you may be wondering, so how will the findings of this project benefit future work and studies on the use of deep learning models for stock market prediction tasks? The results of the study will be of assistance towards future studies conducted on the use of deep learning models for stock market prediction tasks by providing insights on how to improve the training of the models with the use of training data introduced with variations beneficial towards helping the deep learning models better overcome the difficulty of learning from the training data during training. Using the project findings, future work can be done to build a federated learning system that consists of a network of deep learning models, each trained on a set of training data with a specific variation, to enable them to make more accurate predictions on stock data of a specific variation. The trained local models will then be used to update a centralized global model so that the global model can learn better with the help of the trained local models, improving its weights to be able to make accurate predictions on stock data in general. With that, we have come to the end of the infographics video for the experimental investigation on the effects of introducing different variations to the training data used to train deep learning models, on the ability of these models to learn the task of stock trading action prediction. Hope you enjoyed the video.